All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to be working through a test review for solving systems of equations using the graphing method, the substitution method, and the elimination method. So let's dive right in. As we do these problems, I would highly recommend that you have with you a straight edge of some kind, and especially for these problems that involve graphing, we will need some scratch paper because you won't be able to do all the calculations you need here on this paper here. So let me start by getting some scratch paper, and you get some scratch paper and get a straight edge, and please use a pencil. Okay, so in number one, we have two equations, and we need to solve by graphing. Now notice that neither equation is in the form that would be graphable. So the first thing you have to do is rearrange the terms in order to get y by itself. Remember, in order for us to graph a linear equation, we need to have that equation in the form y equals mx plus b. Okay, where m is the slope and b is the y-intercept. And this is called the slope-intercept form, or slope int. Okay, so let's take our first equation here, 4x minus y equals 3. 4x minus y equals 3. And we have to solve this equation for y. Okay, we need to get y by itself. Our first step will be to move this 4x over to the right side of the equation by subtracting 4x from both sides. Okay, on the left, those 4x's cancel out, and I have negative y equals negative 4x plus 3. Okay, this is one of the reasons I told you to use a pencil, because now in order to get this negative sign to go away, I can just change all the signs. So I can make this positive, and here I'm going to use a little movie magic here and make this negative. So just change all the signs. So the final form will be y equals 4x minus 3. So we now need to identify in this equation what the slope and what the y-intercept is. So the slope, which we represent with the letter m, is equal to 4. But for our purposes, we need the slope always to be in fraction form. So to write 4 as a fraction, we write it as 4 over 1. And remember, students, that the top part, or the numerator, is the rise, and the bottom part, or the denominator, is the run. So in this case, I have a slope of 4 over 1, so I rise 4, and then I run 1 to the right. All right, so that's the slope. And what is the y-intercept? The y-intercept, y-int, which we call letter b, lowercase letter b, is equal to negative 3. Right, so this is where I will start graphing on the y-axis. And now we have to do the second equation. 3x plus y equals 4. So I've got here 3x plus y equals 4. And the first thing I have to do is get y by itself by subtracting 3x from both sides in order to move the 3x over to the right side of the equation. Cancel out those 3x's on the left. I have now y by itself equals, okay, and remember I can't mix the negative 3x with the 4, so I just write negative 3x plus 4. Now let's figure out what our slope and our y-intercept are. The slope m equals -3. This term in front of the x is called the coefficient. Okay, so the coefficient of the x variable in a slope-intercept form equation is the slope. So m equals -3. But remember, we always write the slope in a fraction form. So let's turn -3 into an improper fraction, and that would be -3/1. So my rise, or in this case my fall, okay, will be 3. I'm going to go down 3 in this case, and then I will run 1 to the right. And now let's identify the y-intercept, or b, and that's +4, so we just write 4. So I'll start graphing at 4 on the y-axis. Well, now that we've solved these equations like this, let's go back to our worksheet and let me show you what to transfer over. First, let's transfer the slope-intercept form of the first equation. All right, let's write this arrow here to show that we're just rewriting. And let's write y equals 4x minus 3. And then that second equation, let's write y equals -3x plus 4. So these are the lines that I will now graph. And here we're looking at our coordinate plane. And for the first equation, which I will graph in red, our first equation, remember, we said that our slope was 4, so it was 4/1. And we said our y-intercept was -3, and we start with the y-intercept at -3. So I go to the origin and then count down 3. 1, 2, 3, and I'm going to put a dot there. And from that dot, I will use my improper fraction of the slope, rise 4, run 1. So we'll go up 4 and then 1 to the right, starting at the y-intercept. Up 1, up 2, up 3, up 4, over 1 to the right. Okay. Now it would be beneficial to go to this new point that I just put a dot there and do that whole thing again. Up 1, 2, 3, 4, 1 to the right. The reason we do this multiple times, up 1, 2, 3, 4, 1 to the right, is because when I put my protractor up to it, I want to make sure that I'm really graphing in the line as precisely as possible that a person could do it on this little tiny coordinate plane. So make sure that you've got your dots all lined up there, and then graph in the line just like this. And then if we're going to be really good math students, we will label this line y equals 4x minus 3. When you have multiple lines going down, it's important that you label them. So now let's graph the next line, and I'll do this one in blue. Okay. And in this equation, I have a slope of -3, which we said was fall 3, run 1, and a y-intercept at 4. So I'll start graphing at +4 on the y-axis, start at the origin, go up 1, 2, 3, 4, and put a dot. And now we have to use the slope, which is -3/1. So starting at the y-intercept that we graphed, we'll go down 3 and then 1 to the right. So we'll go back here to this blue dot and go down 3, down 1, down 2, down 3, over 1 to the right. Okay, you see I just drew over that other point. And then we'll do it again, down 1, down 2, down 3, and 1 to the right. And again, down 1, down 2, down 3, and 1 to the right. This assures us that when we finally plot the line in, we're getting it in just right. Okay. So once you feel comfortable, you've lined up all the dots with your straight edge, draw in your line. And let's label it down here, y equals negative 3x plus 4. Okay, so the final step to get the solution to the system of equations is to identify the point on the coordinate plane where the two lines intersect, where they cross. And we see plainly that it's right here. And so what we have to identify as the solution to our system is a coordinate pair consisting of an x-coordinate and a y-coordinate at that intersection point. And that would be starting at the origin. I see on the x-axis it's 1. Okay, so the x component of the solution to the system is 1. And on the y-axis it's also 1. So the solution to the system of equations, consisting of these two equations that we've found here, is 1, 1. Now this is what your paper should look like, but this side work should also be part of the turn-in. So here I'll make sure that we know that this is number 1. And this is what I would want to see to go with each of these graphing problems, so you can prove to me that you know how to solve a standard form equation and turn it into slope-intercept, and that you're clearly able to distinguish the slope and the y-intercept, and that you can transfer that back to a graph and make nice, neat graph. Okay, so number 2 will be on you. And I can see number 3 and 4 are very similar, so I'll just solve one more here in this section. I'll solve number 4. So numbers 2 and 3 will be on you. Let's do number 4, just in case it has some kind of hidden landmines that you need to be aware of. Number 4, I have x minus 3y equals 3 and 2x minus 6y equals negative 24. So this will be a good problem to do, because in both cases, to get y by itself, I'll have to end up dividing out a coefficient in front of y, which means we'll be dealing with some fractions. That's a good one to practice. So let me go back to my side work here. This is going to be number 4. So need a pen that has ink. This is number 4. And so let me just transfer these equations. X minus 3y equals 3. X minus 3y equals 3. And the first thing I have to do is get this solved for y. So I need to start that by moving the x. We'll subtract x from both sides. On the left it cancels out, and I have negative 3y equals. Now I can't mix negative x with 3, but I want that x value to go up front, so I write negative x plus 3. And now I have to get rid of the coefficient in front of the y variable to get y by itself. Well, right now negative 3 is multiplied by y. There is an invisible multiplication sign here sitting in between the negative 3 and the y. So to get rid of it, I have to do the opposite of multiplication, which would be division. And I need to divide every term in this equation on both the left and right side by the coefficient of y, which is negative 3. So I'm going to divide everything by negative 3. Okay? On the left side, these negative 3's cancel out, and I'm left with the y variable all by itself, set equal to this mess over here on the right. So before we start putting pen to paper, let's think about what we have here. We have negative x over negative 3. I want to just go out here in side work and write this out. Negative x over negative 3. This is something we have to become good at. All right, we've got to become good at extracting a fraction out of this and putting the x all by itself, because you know and I know that this doesn't look right. Okay, this doesn't look like anything that we can use when we graph. So this is equal to negative 1 x over negative 3. So can you see that I can pull that fraction out? Let me show you what I mean. I can pull out negative 1 over negative 3, and that can be multiplied by x. And that's starting to look more like a proper x coefficient and x variable that we can use to interpret a slope. So my next step would be to notice that a negative by a negative is a positive. So negative 1 over negative 3 simplifies to just 1/3, positive 1/3. And then we just put that x there. So when I go back to finish writing this, I won't write negative x over negative 3, I'll write 1/3 x. So this is 1/3 x. And now we have to look at this, 3 over negative 3. Well, 3 divided by negative 3 is negative 1. So 3 over negative 3 simplifies to negative 1. And now this looks like something we can interpret. So my slope m is equal to 1 over 3. Remember, that would be the x coefficient. And my y-intercept b is equal to negative 1. Make sure to include that negative sign, negative 1. Okay, so that's the first part. The second part, 2x minus 6y equals negative 24. Let's do that next. 2x minus 6y equals negative 24. We will begin by subtracting 2x from both sides and canceling those out. And now we have negative 6y equals negative 2x minus 24. Okay, and my final step is to divide every single term in this equation by the y coefficient, which is negative 6. Okay, these negative 6's cancel, and I have y equals. And now I have y equals negative 2x over negative 6. So this we need to address, negative 2x over negative 6. That can be written as negative 2 over negative 6x. And that negative by a negative goes away. And I can simplify 2 over 6 down to 1 over 3 by dividing both the numerator and denominator by 2. So what this boils down to is 1 over 3x. All right, so let's bring that back here. 1 over 3x. And now I have negative 24 divided by negative 6. Well, a negative divided by a negative is a positive, and 24 divided by 6 is 4. So I write plus 4. Therefore, my slope, m, is equal to 1 over 3. And my y-intercept, b, is at positive 4. Okay? So, notice something. Both of my slopes are 1 over 3. Okay? So what were we talking about when we said same slope? How many solutions will a system of equations have that has two equations with the same slope? All right? Same slope indicates parallel lines. Okay? If you look at the y-intercepts, they're different. So I should say same slope, different y-intercepts. Indicates parallel lines. And parallel lines Okay. Parallel lines have no solution, which sometimes you see represented as a 0 with a line through it. No solution. But we have to graph it. Like, it's not enough just to know this. Let's see if we're right. Let's go back here and transfer our slope-intercept form equations back to this graph. I'm on number 4. Almost started writing on number 3. Okay. This first equation becomes y equals 1/3 x minus 1. And the second equation becomes y equals 1/3 x plus 4. Okay, and now we need to graph these. Well, I'll do the top equation in red, and that top equation has a slope of 1/3 and a y-intercept of -1. So I start at -1 on the y-axis right here, and I go up 1 over 3. Rise 1, run 3. Up 1, starting at the y-intercept, up 1 over 1, 2, 3. Again, up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Until you've got several dots all kind of in a line. And now we connect all those dots and we draw in our line. And this line, remember, we have to label it. This is y equals 1/3 x minus 1. And now I'll do the second equation in blue. And remember what we were hoping for here. Same slope indicates parallel lines, different y-intercepts, okay? What we're looking for here is a parallel line situation. So I start graphing at +4, which is my y-intercept. So I start at the origin, go up 1, 2, 3, 4, put a dot. And now I go up 1 over 3. Up 1 over 1, 2, 3. Okay? Up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Okay, let's connect those dots. Okay. And we see here that we do indeed have what look to be parallel lines. Let's label this one y equals 1/3 x plus 4. And what we write here is no solution. Okay, you could also write this. And that is your answer right here. Put it in a box. And make sure that you have your evidence, right? This is your evidence right here. This is your side work. And if you use a straight edge here for both the side work and for the graphing, it will really help you just have a very organized understanding of what you're doing. All right, so those are the two graphing problems that I'm going to do, numbers 1 and 4. Let's move down to solving these systems using substitution. Let me just check the second page to see what's going to be coming our way. Okay. All right, so let's take a look at number 5. Remember what we have to do in substitution. We have to solve either the top or the bottom equation for one of the variables. So in this case, it would be easier to solve the top equation for the x variable. Okay, so let's do that first. Let's write out x plus 3y equals 9. And to get y by itself, first we'll subtract x from both sides. The x's cancel on the left, and I have 3y equals negative x plus 9. Now I divide every term by the y coefficient. Again, that straight edge coming in handy here to keep everything organized, which is 3, so I'll divide everything by the y coefficient of 3. The 3's cancel on the left, and I have y equals. Now I hope at this point you can look at negative x over 3 and see very plainly that it's negative 1/3 x. Okay? If you didn't understand that, go back in the video where I discussed that in problem 1, or rather problem 4. The first equation in problem 4, we went into some depth on that. And now I have plus 9 over 3. Well, that just reduces down to 3 plus 3. Okay? So now I have an equation solved for y. All right, I think before I said I was going to solve it for x, but I solved it for y. And that's fine. I actually think it would have been easier to solve for x, but for some reason my brain was still in turn everything into slope-intercept form. So I'll go ahead and run with what I've got. So now we have y equals negative 1/3 x plus 3. And this is a situation where I've created a hardship, but we're going to do it. We're going to fight on. If you want to solve the equation for x, your life might be somewhat easier. Okay, so what we're going to do is we know that y equals negative 1/3 x plus 3. So I'm going to go into my second equation. And now I see that I've really set myself up for pain and suffering. But that really more or less is my job description as an algebra teacher. Okay, so we're going to write 4x minus 2 and then open parentheses, and we're going to plug in this, negative 1/3 x plus 3. Negative 1/3 x plus 3, close parentheses, equals negative 6. Okay, so I have 4x. And now I have to distribute multiply this negative 2 through every term in the parentheses. So that's negative 2 times negative 1/3. Okay, this is side work for number 5. Negative 2 over 1 times negative 1 over 3. Okay? So we just multiply across the top and across the bottom. Negative 2 times negative 1 is positive 2, and 1 times 3 is 3. So that's positive 2/3. So I write plus 2/3 x. And now I have negative 2 times negative 3, which is minus 6. And that all equals negative 6. All right, so I can add 6 to both sides. Okay, and that cancels these out. And all that I have to do now is combine these like terms, 4x and 2/3 x. Easier to do in side work. I need 4 to be written as a fraction with 3 in the denominator. So remember, 4 can be written as 4 over 1. And if I need a 3 in the denominator, I can multiply this fraction by 3/3. Okay, so 4 times 3 is 12. And 1 times 3 is 3. So 4 can be written as 12/3. And you see that 12 divided by 3 is 4. So all we've done is change the form. So I can write here 12/3 x plus 2/3 x equals -6 plus 6 is 0. Okay? So what is 12/3 x plus 2/3 x? Well, when you have common denominators like this, you just add the numerators. So that's 14/3 x. So I have here 14/3 x equals 0. And to get x by itself, I multiply both sides of the equation by the reciprocal of the x coefficient, which in this case would be 3/14. On the left side, the 3's cancel out and the 14's cancel out. Everything cancels out, leaving x by itself. And x equals 0 times 3/14. And anything times 0 is 0, so x equals 0. I promise you, if you had solved this problem for x instead of for y, like I said I was going to do, but then I did it wrong, if you would have solved it, you would have gotten to 0 much easier and without needing to do these fraction conversions. But it still works, you know. You can't really go wrong with these. So even if you choose the difficult path, you can still finish. So now I have half of my answer. I have the x-coordinate of the solution as 0. And now all I have to do is go plug that back into one of my equations to get the y-coordinate. And it just so happens that I have created an equation, right, that I can use to solve for the y-coordinate. I have y equals -1 over 3, open parentheses, 0, close parentheses, plus 3. Well, y equals -1/3 times 0 is just 0. Okay, so 0 plus 3. And 0 plus 3 is 3, so y equals 3. Well, now I've found both the x and the y coordinates, right? If you did this the other way, where you solve for x, then you'll be plugging this equation back into something else, but you'll still find out what y is. You might have to work it out a little bit, but you'll get there. So whatever way you get there, your coordinate should be 0, 3. That's the solution to the system, and that is what goes in the box. So this is an equation with exactly, or this is a system with exactly one solution, and that solution is at 0, 3. Okay, now looking at number 6, I can tell you just as a hint that you'll want to solve the second equation for y, all right? Start there by solving the second equation for y and then follow this pattern. Now, per my first period student, okay, who is an excellent baseball player and very outspoken in a positive way, tells me what he needs. He says when he sees this, you know, 1 hour later, 1 day later, it's difficult to understand what were the first step, second step, third step. So I really took that to heart because that's a great point. Let me outline the first step. So this is what I did first. The first thing is I solved this equation for y, okay? This is what I did. This was my first step. And then in my second step, I plugged in this right here, which I'll highlight. I plugged in this right here into the second equation, right? That's where this went. And I'll outline step 2 here, right? I did all this work right here, and I solved for x. Okay, that was step 2. And then in step 3, I plugged in what I found x to equal, which was 0. I plugged it back in to an equation to solve for y. All right, so now I need another color. I guess I'll use green if it works. This is step 3. Right? I solved an equation to find the y, and then I plugged it all in to get my solution. Okay? So, there it is. This is how you do solving systems of equation using substitution. I did a little bit more work than was needed here. I should have solved for x and not y, but we still got the answer. Okay, so you do number 6, and I'm looking here at number 7 and number 8, and I don't see any real problems here. You should be able to do number 7 and 8 as well. Okay. Number 9. This one's easy. All right. I can see that you can solve this system by either subtracting x, or you could add y. To eliminate x, you would subtract. To eliminate y, you would add. You can do that, right? You can solve this system using elimination. Pretty confident about that. Here in number 10, this is one that would be good to work because we have to multiply the top equation by something. All right? Let me demonstrate that. You would need to look at this. There are no common coefficients. The coefficient in front of the x here is 1, right? The coefficient in front of the x here is 2. The coefficient in front of the y here is 5, and in front of the y here is -7. So I have to multiply my top equation by something. Every single term in the top equation needs to multiply by something that will turn this 1x into a 2x. And the thing that you need to do is multiply it by 2. All right? And that will be distributed to every single term in the top equation. So here's how I recommend that you do this. Okay, let's write this out. 2 times 1x is 2x. 2 times 5y is plus 10y. Okay, equals 2 times 20 is 40. All right, now bottom equation, we just rewrite. We don't change it. You got 2x minus 7y equals negative 45. Now take your straight edge, draw a line. And now how are you going to eliminate the x variable? Because that's obviously the one you want to eliminate. Well, you would eliminate it using subtraction. Okay? So 2x minus 2x is 0. They cancel out. 10y minus negative 7y. Okay, so here's 10y minus negative 7y, right? What we need to do here is recognize that we have a double negative, and that double negative comes together to be a positive. And so 10y minus negative 7y is 10y plus 7y, and that's equal to 17y. Okay, so down here I'll write 17y equals, and now I have 40 minus negative 45. 40 minus negative 45. That's the same thing as saying 40 plus 45. Okay, and that equals 85. Okay, so over here I put 85. Now if we divide both sides by the coefficient of y, which is 17, all right, cancel out the 17s. We have y equals 85 divided by 17, which I think is 5, but I could be wrong. All right, how would we come about the answer? All right, this is what I want to show you. We can prime factor the 85. All right, that would be 5 times, let's see, 5 goes into 8 one time with 3 as a remainder. All right, so that's 1, and then 5 goes into 35 as 7 times. All right, so that's, there it is. We found it. All right, both these numbers are primes, so there's nothing left to do. It's the same thing as division. So now we say 85 over 17 reduces down to just 5. So y equals 5. Now what do we do with that? Well, we need to plug that back into one of our equations and solve for x. The original equation, x plus 5y equals 20, is very well suited for this purpose. So I will write x plus 5, open parentheses, 5, close parentheses, equals 20. All right, so now I have x plus 5 times 5 is 25 equals 20. You can subtract 25 from both sides. Cancels on the left. I have x equals 20 minus 25, and that's negative 5. Okay, so now I have y equals 5, and I have x equals negative 5. So the solution to my system, x comma y, is negative 5 comma 5. Quick little test. What quadrant is this in? All right, this is in quadrant 2, or top left. Okay, so let's go ahead and finish out by outlining what those steps were again. My first step was to get the y variable by eliminating this. So this was step 1. So I'll do it in red. Step 1 right here. And then step 2 was to plug that back into one of the equations. All right. And what I was plugging back in was that we found in step 1 that y equaled 5. And so I plugged that back in to my other equation. Okay. These other problems look good, except for number 12, which I'll give you a little bit of help on. Before you can even analyze number 12, you need to change the form of this equation. and you need to make sure that you have it with both the x and the y on the same side of the equal sign. So I have here x equals 2y minus 3. And to get y on the other side, I have to subtract 2y from both sides. So I have negative 2y plus x equals negative 3. Okay. So now that I've rewritten this equation in this form, I can bring down the second equation and just write it. Oh, I didn't arrange this correctly. So I need the negative 2y to go after the x. So all you can just move these around. You can flip these like this and rearrange them. It's okay. So here I have x minus 2y equals negative 3. And my second equation, 2x minus 3y equals negative 5. This is the equation that you would start to solve on. And notice that you have here a 1 coefficient and a 2 coefficient, and here's a 2 and a 3. Well, you got to do something. I would recommend multiplying everything in the top equation by 2. All right, and we're going to write our result up here. 2 times 1x is 2x. 2 times negative 2y is negative 4y. Equals 2 times negative 3 is negative 6. Okay, and the bottom equation just gets rewritten. 2x minus 3y equals negative 5. All right, and I'm going to leave it to you to solve from there. Okay, well, this video has gone on long enough. I hope this was helpful. I gave you a partial solution here. You need to finish this. So the only ones that you were straight up given the answers to were 10, 5, 4, and 1. So 1, 4, 5, and 10 with a partial on 12. So you need to do number 2, number 3, number 6, number 7, number 8, number 9, number 11, and then you need to finish number 12. But I've got it set up for you here. Okay. 12 was hard because we had to go through this rigmarole of rearranging the terms first. Okay. Well, I hope this review was helpful to you. If it was, please consider giving this video a like. Please leave a comment. The comments are what fuel all the views. And if you would, please subscribe to the channel. Hit that notification bell. Post this to Instagram. Post it to Snapchat. Post it to TikTok. Whatever it is. Facebook. However you communicate. I know none of you use Twitter, but post it to Twitter. Let people know that I'm doing this. And please get the word out so the channel gets more views. Appreciate your help.